Hi, continuing with chapter 4, section 4.4 and 4.6, we are going to combine them because they are talking about both of these sections. They talk about bases of a vector space. So there is a uniqueness theorem, the unique representation of the bases. It says that if B is a set of n vectors b1, b2 up to bn, be a basis for a vector space V, then for each x in V, so any vector in V, there exists a unique set of scalars C1, C2, C up to Cn, such that we can write x as C1 B1 plus C2 B2 plus dot 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 plus Cn Bn. In other words, we say that there is a unique representation of or a unique way of writing x as a linear combination of the vectors of the base. Now, when we write it as a linear combination of B, like shown over here, then these C1, C2, and Cn are called, up to Cn, are called coordinates of x relative to base B, or just B coordinates, because usually the vector will be given in terms of the standard bases, E1, E2, E3, and so on. So when we convert it to another base, or when we write it as a linear combination of some other vectors other than the standard unit vectors, then we say these are the coordinates of x relative to B, or the B coordinates, and this is the representation we use. If you see something like this, then it means this is here x has been represented, or x is represented in as a linear combination of basis vector of A. So A might be another base. The mapping which takes x to the B coordinates of x is called the coordinate mapping determined by B. So the vector equation x is equal to C1 B1 plus C2 B2 plus so on. This can be written as a matrix equation where it says x bar, which means the vector with the in the coordinates, in the Cartesian coordinate or in the standard basis, will be equal to PB. So what is PB? This is a matrix which is actually the matrix of the coefficients of the B1, B2, B3, and Bn. So these will be times the vector So this is how we can write in the matrix form, and then the P3 is the matrix which consists of the columns of the basis B, and this matrix is called the change of coordinate matrix from basis B to the standard basis in R. And okay, so mind these words, or remember these words. So P3, which consists of column which is a matrix with columns equal to the standard the basis vectors B from B, and it is called the change of coordinate matrix from basis B to the standard basis in Rn. Since the columns of P3 form a basis for Rn, PB is invertible. Okay? by IMT, and so we can multiply both sides by the B inverse. So it gives us this. So we get a PB inverse over on this side, and this PB inverse goes away because of the inverse multiplying by the inverse. And you know why we are multiplying by the PB inverse on the left side. Okay. So this will be called, this inverse matrix is called the transition matrix. Okay. So the process of changing the coordinates is called change of basis. So over here, so this is more explanation of what we just said, that if B and B prime, so these are two different bases, and they have two different kinds of vectors in them, but the number of vectors must be the same. So let these be two bases for a vector space V, and let's say that we have represented, or we know what is the representation of the vector, whatever vector we have, in terms of the base B. Okay, so because you see B prime, sorry. So these are vectors from B prime. So U1, U2, so on. These are vectors from B prime, and V1, V2, so on are vectors from B. So we say, so this matrix, the matrix of the coefficients, is the transition matrix from B prime to B. Okay? B prime to B. And the coordinate matrix, okay, going back here, the coordinate matrix, or the B coordinate, okay, just go, yeah, change of coordinates matrix from basis B to the standard basis in Rn. So the basis, the matrix that helps us change the coordinates from the basis B to the standard basis in Rn, that is called the change of coordinate matrix. And the matrix that changes the coordinates of a vector from B prime to B is called the transition matrix. And this process is called change of basis. Okay? So how do we use it? That's what we want to see. Okay? So here is some explanation given, like what are you expected to do when you get a question like this. So it explains over here that the P, just the P, or sometimes we are writing it in like a strange way. I'll show you in a minute. So the coordinate matrix, so the PB we can say here. So this is equal to the C1, C2, and so on. So that will be the, if you are getting it from to change the vector to X to the standard basis, then this is the change of coordinate matrix. But or you can say this is the matrix, change of matrix, or transition matrix from B prime to B. Okay, and P inverse will be the transition matrix from B to B prime. So to find the inverse, the transition matrix P inverse from B to B prime, perform the row reduction as follows. So what we do, we will put the two matrix, augment the two matrix. So just remember this thing, the one which is saying where we are starting, you put it on the right side, right, and the one to which you are going, you are changing, you put it on the left. That's what how this is. To find the transition from B to B prime. Okay, so we are going from B to B prime. So this is B and this is B prime. So this is how we are going. So we sometimes write it as P from B to B prime. Okay, so arrow goes this way. This is kind of strange, but that's how it is. And what you will do here, you will perform your row operations and try to convert the left matrix into a identity matrix. Augmented matrix, remember I said put a straight line in between. In the book they are not putting it. Okay, so once you get the left matrix as an identity matrix, the right one will be the P inverse matrix. Now note, a basis B is in a vector space creates a new coordinate system, and this concept is important in crystallography. Change of coordinates also helps to compute tedious calculations in calculus integration in a simpler way. If you recall, when we use a substitution, so it means we are going into another space. Okay, so let's look at examples. First one is, we are given B1, B2, and we are given an X vector. Now note here, all these vectors, when you see it like this, B1 is equal to 2, 1, what it means is this is in standard with the standard basis vectors. So this means B1 is equal to this means B1 is actually equal to 2E1 plus E2. We don't need to write it like this, but you should understand that when they are written like this, it means they are we are using the standard basis vectors. Okay, so here it says that find the change of matrix, coordinate matrix from B to the standard basis. So remember, from B to the standard basis, so we had this situation that we have X, remember X is equal to P, we wrote here B, remember, times X B. So what is the change of coordinate matrix from B to the standard basis? This the matrix that you will obtain by using the columns of B. So the PB will be 2, 1, negative 1, 1. That is PB. Now it says find the change of find XB. Okay. Now from here, from this equation, or we saw it before as well. So from this equation, we can say PB inverse times X equals the coordinates relative to B, or the coordinate vector relative to the basis B. So we need to find B inverse. So it's a 2 by 2 matrix, so inverse should be pretty easy. So you can even find it in the first the portion here, where the first part. So I can say B prime inverse, sorry, not prime, inverse is equal to 1 over the determinant. So what is the determinant? It's going to be 2 times 1. So 1 over 2 into 1. So 2 minus negative 1 into 1, so it becomes 2 plus 1, 1 over 3. And then what we do, we exchange the 1 and the 2, and the other along the other diagonal the signs change. And now if you want, you can write it as 1 over 3 times, so 1 over 3 times, okay, and now I have to multiply it by the x vector which is given, okay. Therefore the vector x relative to the b basis will be equal to 1 over 3 times 1 1 negative 1 2 times 4 5. So we get 1 over 3 times, so 4 plus 5 9 minus 4 plus 10 6, and then multiply each answer, each the entry by 1/2, so 1/3. So we get 9 over 3 which is 3, and 6 over 3 which is 2. So your xb is 3 2. Now looking at the second example, so now we are again given 4 5 and 6 7. So these are base vectors. The base is this, b1 b2 form a base vector. So we want to find the xb. So remember x, so this time we want to find x. Xb is given and we want to find x. So remember x is equal to the pb xb. So we have the xb given. So what is the pb? Just the 4 5 6 7 times x, which is 4 5. So multiply, we get 4 4s are 16, 16 plus 30. What do we get? 46. Okay. So 4 5 6 7, and we multiply by 4 5. So 4 4s are 16, 16 plus 30, and the second is 20 plus 35. So 46, and this gives us 55. So these are the coordinates in standard basis. Let me stop here. We'll do the next examples in the second video.